So in this problem, we're given a compound, ClF2O2PtF6, and we're asked to find the mass percentage of each element in the compound. So to do that, we have our compound, ClF2O2PtF6, and we're going to imagine that we have 1 mole of this compound. And so if we have 1 mole of this compound, that means we can break it up and find how many moles we have of each element in the compound. So if we have 1 mole of this compound, we have 1 mole of chlorine. We have 6 plus 2, so that's 8 moles of fluorine, 2 moles of oxygen, and 1 mole of platinum. And let's look at our general formula for computing the mass percent. So the percent mass of a given element in a compound is the mass of X, so whatever mass contributed by chlorine or fluorine or oxygen or platinum, over the total mass of the entire compound. We multiply that, which would be a decimal less than 1, by 100% to get our percent mass. And so to do that, we convert these molar amounts to grams, and then divide the grams contributed by each over the total mass, and we get our percent mass. So let's get started. So we're going to start by converting the molar amounts to grams using the molar masses we find from the periodic table. So we have 1 mole of chlorine. We're going to multiply that by the molar mass of chlorine, which is 35.453 grams of chlorine per 1 mole of chlorine. Moles chlorine cancels out, and we get 35.453 grams of chlorine. We saw that we had 8 moles of fluorine multiplied by the molar mass, 18.998 grams of fluorine per 1 mole of fluorine. Moles of fluorine cancels out, and we get 151.984 grams of fluorine. 2 moles of oxygen, the subscript 2 on oxygen, 15.999 grams oxygen per 1 mole oxygen. Moles cancels, leaving grams oxygen, 31.998 grams oxygen. And finally, 1 mole of platinum. Multiply by that by the molar mass, 195.08 grams of platinum per 1 mole of platinum. Moles of platinum cancel out, so we get grams platinum, 195.08 grams of platinum. So of course, moles of each cancels out, leaving us with grams chlorine, fluorine, oxygen, and platinum. And so what we have here, these are all of the masses contributed by each element in the compound. So if we add these up, we get the total mass. The sum of all of these gives us the total mass of 1 mole of the compound, which is 414.52 grams in 1 mole of our compound ClF2O2PtF6. So this is our molar mass for our compound. Now we're going to divide each of the masses contributed by each element by the total mass to get the mass percentage. That is, the percent of the whole, the part of the whole that each of our elements is in the total compound. So for chlorine, we saw that we had 35.453 grams of chlorine in our total compound. That's the amount of the mass of the total compound contributed by chlorine. And we'll divide that by the total mass, which is 414.52 grams for the compound. Multiply that by 100%, and we find that we have 8.553% chlorine. We're going to be going to 4 significant figures in this problem. Now, fluorine, we had 151.984 grams of fluorine. That's the contribution of fluorine from the 8 moles of fluorine we had. And that's out of a total mass for the compound of 414.52 grams total. That's a decimal, so we multiply by 100% to get that into a percent. We find that fluorine has a percent mass contribution of 36.67%. Moving on to oxygen. 2 moles of oxygen contributed 31.998 grams of oxygen over a total mass of 414.52 grams total times 100% gives us 7.720% oxygen. And finally, platinum. 1 mole of platinum, 195.08 grams platinum contribution in this compound. Out of course, the total, 414.52 grams total. Multiply by 100% to get our percent mass contribution, 47.06% platinum. So notice our original formula was Cl F2O2 PTF6. Quick glance, if we say we have 1 mole of this compound, there's 8 moles worth of fluorine, 2 of oxygen, only 1 each of chlorine and platinum. But it's interesting that the 1 mole of platinum, the substantially higher molar mass of platinum than any of the other elements, causes the percent composition of platinum to be almost half of the entire compound. So just something interesting to note. So first, what we did was we calculated the mass contribution by each element. And by pretending we have 1 mole of this substance, we could have also pretended we had 10 moles of this substance and multiplied all the subscripts in the formula by 10. Simplest just to use 1 mole and say we have 1 mole of chlorine, 8 of fluorine, 2 of oxygen, and 1 of platinum. We convert from moles to grams for each element. We sum up the individual masses to find the mass of 1 mole of our compound, which is the total mass. Then we divide each individual mass contributed by each element by the total, and then multiply by 100%. Because when we divide the mass of each element by the total is always going to be greater than the contribution of each. So that's going to be a value between 0 and 1, a decimal. We multiply that by 100 to get a percentage out of 100%. And that's what we have. Chlorine contributed 8.553%. Fluorine had a contribution of 36.67%. Oxygen had a mass percent of 7.720%. And platinum's mass percentage was 47.06%. All of these are out to 4 significant figures.